Hello students, now we are going to start worksheet 2, third question of chapter 3. Find the decimal representation of the following rational numbers. Okay, so these are the rational numbers. So let's see. Okay, now here first question is minus 27 upon 4. So we have to convert this rational number into decimal. Okay, so previously the question number 1 we have done. See here, this one. So whenever in the denominator you have these numbers, like if you have in the denominator 2, you're going to multiply it by 5 to get 10. If you have 4, you're going to multiply by 25, you get 100. If it is 8, you multiply by 125, you get 1000. And 16, you multiply by 625, you get 10,000. And either ways also, if 625 is there in the denominator, you're going to multiply by 16. Same, 125 is there, you multiply by 8, you get 1000. If 25 is there in the denominator, you multiply by 4, you get 100. Same, if 5 is there, you're going to multiply by 2. So you just remember this thing. Whenever these numbers are there in the denominator and you have to change it into decimal, the rational number you have to change into decimal representation, that time you are going to use these pairs. Okay, so here in this question 27 upon 4, we have 4 over here. So as we saw, what we are going to do, 27 upon 4, we are going to multiply by 25. Okay, so when we multiply 25 into 4, it is 100. So up also we are going to multiply by 25. So what we get, 27 into 25, we get 675. Okay, now here 100 is there, so we are going to give the point as per the number of zeros. So I will write the numerator 675 and down how many zeros we have, 2. So right from the units place I will start counting. So 1, 2. So I will give the point over here. So this is 6.75, and in the question it was minus sign, so I will write minus 6.75. Okay, now next question is minus 37 upon 60. Okay, now here in the denominator if we see, there is 60, and previously what I told you when we did this thing, only if these numbers are there in the denominator, 2, 5, 4, 25, 8, 125, 16 and 625, then only we are going to do this method. Okay, but here 60 is there, because if you take the prime factor of 60, see, 2 3s are 6, 2 15s are, 3 5s are, 5 1s are. You have 2 and 5, but you have 3 also over here. Okay, so that is why we are not going to do this method. We are going to do long division method in this. Okay, so let's do it. So the numerator we are going to write it inside and the denominator out. Okay, now here 37 is smaller than 60, so what will write, 0 and point, so here 0 will come. Okay, this is 0 and decimal point we have given, so 0 comes over here. So now 6, this is 60, but 6 ka table you can see, 6 6 are 36 and we have 37, so 60 into 6 will be what, 60 multiplied by 6, 360. Okay, see, I took 6 6 are 36 and this 0 we gave here. So when we subtract, what we get, 10. So already point is there, so 1 0 will come. Okay, now 100, like 6 2s is what, 12, so 120 will come. 120 is bigger, so I will take 60 1s are 60. So 100 minus 60 is what, 40. If you subtract this, you will get 40. Now for decimal point is there, so I will put one more 0 over here. Now again 6 6 is 36 and 6 7s are 42. If I write 42, it will become 420, right? So I will write 60 into 6 only. 60 into 6 is 360. Okay, so after subtracting this, what I will get, 40. Okay, 10 minus 40 I will get. Again point is there, so 0 will come and then again it will repeat. 60 into 6, 360. Again 400 minus 360 will give you 40. So this 400 is repeating now, right? So only my 66666 is repeating. Okay, so what we'll write? Minus 37 upon 60 is equal to, see, minus sign is there, right? I will put minus 0.616, and I will put the bar sign only on this 6 because only that 6 is repeating. Okay, so this is the answer. Okay, next question. Okay, next question 3.3, minus 18 upon 125. Now here if you see, we have 125 over here, and previously what I showed you, that if these numbers are there in the denominator, 16, 625, 8, 125, 4, 25 and 2 and 5, then we are going to multiply by each other. Okay, so what we have here, see here we have 125. So here see 125 is there. So what we are going to multiply now? 8. So we'll get what? 1000. Okay, so minus 18 upon 125 you multiply by 8. So up also you will multiply by 8. So 125 into 8, what was there? 1000. Okay, and when you multiply 18 into 8, what you get? 144. Okay, now I will write the numerator 144. Now how many zeros are there here? 1, 2, 3. So right from this side, from the ones place I will start. 1, 2, 3. 3 zeros are there. So 1, 2, 3. So I will give the decimal point over here, and here I will put 0. And there is minus sign, so I will put minus 0.144. Okay. Now next question. Minus 15 upon 8. Again here see denominator, it is from the pairs what we have seen earlier. Okay, 8 is there. So we are going to multiply by what? 125. So 15 upon 8 multiply by 125. So up also we will multiply by 125. So 8 into 125 is what? 1000. And 15 into 125 will give you 1875. Okay. So now what I will do? I will write the numerator. And how many zeros are there? 1, 2, 3. So from here I will start 1, 2, 3. So I will give the point over here. And minus sign. So I will put the minus sign. So it is minus 1.875. Okay. So we have completed question number 3. Now question number 4 of worksheet 2. If the number 1 upon 2 plus 2 upon 3 plus 3 upon 4 plus 4 upon 5 is expressed as a decimal, will it be terminating or non-terminating? Justify your answer. So it means these rational numbers and they have given addition. So after solving this we have to express this as a decimal. So not by long division method but by only seeing the denominator and all, we have to tell whether it is a terminating or non-terminating. So let's see. Okay, now see here. These are the rational numbers and addition is there. So first of all what we will take out? The LCM. Okay, so how to take out the LCM? What it is? 2, 3, 4 and 5, right? So 2 ones are 2, 2 twos are 4, 3 comes down, 5 comes down as it is. Again 2 ones are 2, 3 comes down, 5 comes down, 3 ones are 3, 5 ones are 5. So what I got? 2 twos are 4, 4 threes are 12, 12 fives are 60. So what is the LCM? 60. So in the denominator we should get 60. So let's do it. So 1 upon 2. Now 2 I will multiply by what? That I will get 60. So if I keep this 2 aside, that one. So what is this? 2 3s are 6. 6 5s are 30. So into 30 if I do, and up also I will multiply by 30. Plus 2 upon 3. Again here, if I keep this 3 side, what remains? 2 2s are 4. 4 5s are 20. Okay, so up also I will multiply by 20. Then 3 upon 4. Okay, so 4 I will get 2 2s are 4. This is 2 2s are 4. So what remains? 3 5s are 15. So into 15 plus 4 upon 5. So if I keep this 5 side, what I get? 3 2s are 6, 6 2s are 12. So into 12. Okay, so now what I got, 1 into 30, 30 upon 60, plus 20 into 2 is 40 upon 60, plus 15 threes are 45 upon 60, plus 12 fours are 48 upon 60. Okay, now we got 60 in the denominator, we will write it as common and we will add the numerators. Okay, so when we add all the numerators, what we get, 163 upon 60. Okay, now this rational number we got, now we have to change it into decimal. Okay, express it as decimal. So by denominator we can express it. Okay, how? So previously we have done question number 2, same, like the denominator has 60. Okay, so we are going to take the prime factor. So how do we take the prime factor? Previously only we did, see here, 60, these prime factors we have done. What are the prime factors of 60? 2, 2, 3, 5, right? So that only we are going to write. So 60 prime factor is what? 2 into 2 into 3 into 5. Okay, got it? See, 60 ka prime factor is these only. If you do 60 like this, if you start doing, you will get these only. 2, 2, 3 and 5. 2 to the 4, 4 3 is 12, 12 5 is 60. Okay, so here in the denominator, for a terminating decimal, we must have 2 or 5 and 2 and 5. Okay, but here we have 3. So this is other than 2 and 5. So this is a non-terminating representation, right? So what we are going to write? The prime factor of 60 is other than are other than 2 and 5, because we have 3 also. Okay, therefore 163 upon 60, otherwise we can write the question also. First we'll write this, 163 upon 60 has a non-terminating decimal representation. Okay, so we have completed question number 4. Okay, now let's start question number 5 of worksheet 2. Justify the following statements as true or false. Now first, 22 upon 7 can be represented as a terminating decimal. So how can we say? We have to look the denominator. Now here in the denominator what we have? 7. Okay, so in the denominator we must have what? 2 and 5, or only 2 or only 5. But what we have, what is the factor of 7? 7 into 1, 7 factor is 7 only. It is a prime number. So this is not 2 or not 5. So it is a non-terminating decimal. Okay, but they told that it can be represented as a terminating decimal. So the answer is false, because it is a non-terminating decimal. Okay, for terminating decimal we must have 2 or 5 or both. Okay, now next question. 51 upon 512 can be represented as a terminating decimal. So what we will see? The denominator 512. So to take out the factor, we will take out the factor over here. 512, last is 2. So start with 2 table. 2 2s are 4, carry. 2 5s are 10, 1 carry. 2 6s are 12. 2 1s are 2, 2 2s are 4, 2 8s are 16. 2 6s are 12, 2 4s are 8. 2 3s are 6, 2 2s are 4. 2 1s are 2, carry 1, 2 6s are 12. 2 8s are 16. 2 4s are 8. 2 2s are 4, 2 1s are 2. If we see, we have all 2s over here, no other number. So it is a terminating decimal. So and it is written what? 51 upon 512 can be represented. So yes, it is a terminating decimal. So the answer is true. Okay, next question. Okay, 19 upon 45 can be represented as a non-terminating repeating decimal. So again the denominator, if we see 45, 5 nines are, 3 threes are, 3 ones are, 5 3 3 are the factors of it. So 3 is there. What we require, 2 or 5, and either here it is 3 other than 2 and 5. Okay, so this is a non-terminating repeating decimal. Okay, and they have written that can be represented. So yes, this is true, can be represented as non-terminating, they have mentioned. Okay, now next question, 3 upon 17 cannot be represented as a non-terminating. So 17, if we say it is a prime number, it is going only in 17 table. So what are the factors of 17? 17 itself. So it is a non-terminating decimal, but what they have mentioned, cannot be represented. So this is what? False. Okay, next, if 3 upon 2 and 7 upon 5 are terminating decimals, see the denominators 5 and here 2, so both are terminating decimals, then 3 upon 2 plus 7 upon 5 is also a terminating decimal. Yes, because see, for when addition is there, we take the LCM of the denominators. So I will multiply 5 here and I will multiply 2 here. So 2 5 is what? 10. And what are the factors of 10? 2 into 5. 2 and 5 are only the factors of 10. So when the factors of denominator are 2 and 5, so it is a terminating. So here when we add this rational number, so the denominator what we get 10, it is a terminating decimal. Okay, so from there we can say that the addition of this is a terminating decimal. So this is true. Okay, next, if 1 upon 4 and 1 upon 5 both have terminating decimal representation. Yes, see, if 1 upon 5 we have in the denominator, so it is a terminating, and 4, what are the factors of 4? 2 into 2, so 2 is there, so this is also a terminating decimal, right? Then 1 upon 5 multiplied by, 1 upon 4 multiplied by 1 upon 5 also has a terminating decimal representation. So see, 1 into 1 is what? 1. 4 5 is what? 20. So 20, what are the factors of 20? 2 into 2 into 5. 2 to the 4, 4 5 are 20. So see, we have 2 and 5, which is a terminating decimal representation. So yes, what is the answer? True. Okay. So in this way we have completed worksheet 2 of chapter 3.